Acid anhydrides. Acid anhydrides are obtained by mixing two molecules of the carboxylic acids. During this process, water is also eliminated from the reaction. The term anhydride means without water, and the anhydrades fall under the category of carboxylic acid derivatives because when you replace the hydrogen in the carboxylic acid with carboxylate ion, then it's going to be the acid anhydride. Acid anhydrides can be classified under two different heads. One is the symmetrical anhydride, and the other one is the unsymmetrical anhydride. In the symmetrical anhydride, you will have exactly the same units on both the sides of the oxygen. So let's take a look into this. So for this one, if you're going to break in the middle, you can see the two groups are essentially the same, right? So these two groups are one and the same. And this is going to be called as ethanoic anhydride since this group has got two carbons. So this is simply called as ethanoic anhydride. In the unsymmetrical acid anhydride, you will have two different groups that are attached to this oxygen, right? So this group right here is definitely different from this group, right? While this is an ethanoic group, this one right here is a methanoic group since you have got only one carbon, right? And they have to be arranged alphabetically. So you're going to combine this together. So ethanoic, methanoic, anhydride. That would be the name for this molecule. So remember, E comes first and then comes M. So this is the IUPAC name for these two molecules. When it comes to the common name, you're simply going to use acetic anhydride for this, since there is only one group. And for this one, this is going to be acidic formic anhydride. Because you can imagine that this part has been derived from acetic acid. So the formula for acetic acid, the structure for acetic acid is going to look like this, right? So this is acetic acid. And this one right here is formic acid. So which means you're going to have HCOOH, right? So if these two acids are combined together, what you will be getting is acidic formic anhydride. Here is the order of reactivity of carboxylic acid derivatives, where we can see that the anhydrides have also been included in this list. So anhydrides are going to be less reactive than acyl chloride, but they are going to be more reactive than esters, carboxylic acids, and amides. Now, the reason why acid anhydrides are more reactive than esters, carboxylic acid, and amides is because they have a very weak base, which can act as a good leaving group. So obviously, you can see the leaving group here is the carboxylate ion, which is a weak base compared to OR minus, OH minus, and NH2 minus here. Acid anhydrides can be converted into esters, carboxylic acids, or amides by reacting with these molecules. Acid anhydride, when it reacts with the alcohol, it is going to give us an ester and a carboxylic acid. When it reacts with water, it gives us two equivalents of the carboxylic acid. When it reacts with amine, it's going to give us the amide and the carboxylate ion. Remember, we have to use two equivalents of the amine here so as to have enough amine for the nucleophilic attack, because the amine might react with the formed carboxylate ion and form the ammonium carboxylate ion. Let's take a look into the mechanism for the reaction of an acid anhydride reacting with an alcohol. So first, to begin with, this alcohol with its lone pair of electrons on oxygen is going to go make a nucleophilic attack on this carbon, and it's going to thrust the electrons, the pi electrons, onto oxygen. So this will be the species that will be formed, and a base will come and abstract this hydrogen to neutralize this positive charge on oxygen. Now in the next step, we needed to let the leaving group leave, right? So as these electrons come in, one of these groups need to leave. So it would be either the OR minus or it would be this carboxylate ion. So between these two, obviously we can definitely eliminate the carboxylate ion since this is the weakest base of both. So these electrons are going to come in and it's going to go to give us the carboxylate ion. So that's going to give us an ester. Okay, and it's going to give us a carboxylate ion. And in the next step, this is going to get protonated to give us the carboxylic acid. So when an acid anhydride reacts with an alcohol, it is going to give us two products. One is an ester and the other one is a carboxylic acid.